Hello everyone, my name is Harshit Soni and I'm a first year graduate student at New York University majoring in data science. In a city as busy as New York, emergency constructions, while addressing critical and sudden infrastructure needs of the city, also cause significant traffic disruptions and diversions. Thus, in this transportation data science project, I explored the effect of emergency permits on road crashes. The aim was to identify key trends and patterns to help formulate policies to mitigate such risks. To pursue this research, I utilized New York City's open data portal for their motor vehicle collision data and emergency permit data, which was sourced from street construction permit data. I analyzed over 15 million entries to identify key patterns and trends. Looking at the data, looking at the number of emergency permits per month, we notice a sudden spike and dip in the year 2020, possibly due to COVID. Similarly, in the year 2021, when the COVID-induced restrictions were lifted by the government, there is a sudden uh, rise in the number of permits issued over the course of year, which is a disregard to the general trend. This again follows uh, the year 2022 again follows by this, and we see a decreasing trend in the number of street permits issued, emergency permits issued. Looking at the number of uh, looking at the boroughs which were the highest recipients of the emergency permits, we notice Queens to be the highest, followed by Manhattan and Brooklyn. Queens could be due to their uh, older infrastructure, Manhattan and Brooklyn due to their denser infrastructure and population needs. The number of crashes per month due to emergency permits, while the permits themselves showed a decreasing trend in the year 2020, the number of crashes caused by them did not show any decline. They remained fairly constant. When we look at the average number of crashes by the hour in general on your left, you would notice a sudden steep decline after 5 p.m. However, that is not so in the areas around emergency construction, the chart on your right. This again signifies the fact that emergency construction in the evening hour might be causing more accidents than general. Looking at the causes, the construction that cause most number of accidents, gas repair work remains the highest and most significant contributor to the accidents, followed by electric repair and water repair. So gas repair basically causes the street to be closed, which causes the higher number of which causes traffic diversion and the increase in volume of the traffic in the nearby areas, again causing traffic collisions. When we look at the driver-induced factors, we notice that the traffic control disregard comes into picture here, which was not so in the general trend. Again on your left, and the crashes causes near the construction on your right. Looking at the streets, when we analyze the top five streets that shows most number of crashes around the construction area, we notice Flatbush Avenue, Atlantic Avenue, 4th Avenue Street, 3rd Avenue, and Ocean Parkway in Brooklyn. In Manhattan, however, we see a decreasing trend, and Broadway remains the most affected area with the construction. 3rd Avenue, 2nd Avenue, 1st Avenue, and Amsterdam Avenue. Similarly, in the Queens, Northern Boulevard, Queens Boulevard, Jamaica Avenue, Hillside Avenue, and Francis Lewis Boulevard. Similarly, for Bronx and Staten Island. In this project, the key findings were that the emergency construction permits experienced a sudden spike around post-COVID era. However, the current trend shows a declining trend in the emergency construction permits issued in the city, possibly due to the gradual modernization that has happened. However, the number of crashes caused by them did not show any decline. Among the top five causes of the crashes, driving inattention and traffic control disregard again are major contributors. This underscores the challenge of maintaining driver awareness and ensuring that the drivers follow the traffic advisory properly. Boroughs with a denser infrastructure and population show higher number of crashes as compared to the other boroughs. Thus, in conclusion, we can say that emergency constructions, by their very nature, cannot be really predicted. However, we could take proactive measures to work on infrastructure that we know would be breaking very soon, and we have a gradual work towards them instead of causing sudden disruptions in the traffic. Moreover, steps must be taken to effectively communicate the traffic disruptions that are going on in the city, possibly due through SMS or some other methods. And we need to educate and make the drivers aware of the way they need to behave in and around the emergency construction areas. Moreover, this research could be further refined through use of LION database, which is the dataset for the New York City's street names, linking it to the actual and exact location in the geospace. So I conclude my research presentation from this, and I thank National Northeastern Big Data Innovation Hub, US Department of Transportation, National Student Data Corp, and my mentor, Emily Rothenberg, for her continuous guidance and support. Thank you.